Hello students, today we'll see grade 9 physics, that is unit 2. Last time we have seen about grade 9 physics unit 1 about vectors. Today we'll see unit 2 about motion in one dimension or one-dimensional motions. And don't forget to subscribe the channel, like and share the videos. And if you have questions, write us on comment. Okay, hello students, my name is Theodore Sizao and I'm your physics teacher. Today we'll see grade 9 unit 2 physics, that's one-dimensional motion or motion in one dimension. And in this part we'll see about motion in 1D only. First, let us see what is the definition of rest and motion. What we mean by rest and motion? When we say at rest or rest, if the velocity of the object is what? Zero. That means if the object is not in motion or if the object is not moving, that means stationary. And if the object is in motion, the object is moving with some speed or velocity in some direction. Therefore, when we say the object is at rest, it indicates that the object is stationary, and when we say the object is in motion, the object is moving with some velocity. And the other thing is types of motion. We have three types of motion: one-dimensional, two-dimensional, and three-dimensional motion. Therefore, we will see about only one-dimensional motion, that is along x or y direction. But in two-dimensional, both x and y, this one is x and y, and this one is what? X, y, and z, three-dimensional. But this one is in along x or y or what? Z. Only the one direction. Okay. Particles or point mass. The smaller particle of the matter is what? Zero dimension, which can be described its mass and position is defined as a particle. And when we see distance and displacement, they have a big difference. When we say distance is what? The actual path or length covered by a moving particle in a given interval of time. And if the particle starts from A, from this point, and reaches point C through point B, that means from A to C he moves such distance, from B to C as such a distance, then shown in the figure, then the distance traveled is equal to what? A to B, that is AB plus what? BC. Because he moves in such a manner, distance is the path or the actual length covered. Therefore, he moves to point C in such path. Therefore, the length AB plus BC is the magnitude. Therefore, AB is 3 and BC is what? 4, and the distance is how much? 7. Then distance is what? Scalar quantity, as we see last time. And dimension of distance is what? L to the power of 1 only. M to the power of 0 means it's cancelled, and T to the power of 0 is 1. Therefore, the dimension is only what? L. And the unit, its SI unit is what? Meter. But the displacement is the change in position vector. That is a vector joining the initial to the final point. The displacement is a vector quantity, but distance is scalar, and the dimension is similar, that is L only, and the units also similar. They are measured in meters. And in the above figure, the starting point is A and the last point is B. Therefore, the displacement is from A to B, that is this one, displacement. Therefore, to get the displacement A to C is equivalent to what? Vector AB plus BC. And you can get by using Pythagoras theorem, 3 square plus B square. And finally, you can get the value of 5 meter by using Pythagoras theorem. And S1, S2, S3, Sn are distance of a body. Then the total net displacement of the vector is the sum of this. And comparison between distance and displacement, the magnitude of the distance is equal to the minimum possible distance between the 2 points. The displacement magnitude is the minimum or the shortest path of the distance or the movement. for the moving particle, distance can never be negative or 0, while displacement can be. Displacement can be negative or positive, but distance is always positive. Positive. Distance is greater than 0, always. And displacement is what? Less than 0, that means or 0 or negative. That means either negative, positive, or 0. But distance is always greater than 0, cannot be negative. If the motion between 2 points displacement is single value, while the distance depends on the actual value, so can have many values. And for a moving particle in a distance can never be decreased, and the general magnitude displacement is not equal to what? Distance. For here, RA and RB is the position vectors, and the particle initial and final point, and the displacement is what? RA minus RB from this up to this point. Okay, sample problems which is related to distance and displacement. There are so many. I'll show you only problem 1. A man goes 10 meters towards north and then 20 meters towards east. Then displacement is how much? Therefore, you are asked to calculate the displacement. First he moves at 10 meters north and then east. Therefore 10, then how much? 20. Therefore this one is the displacement. Therefore you can apply Pythagoras theorem. Therefore R is equal to under radical of 10 square plus what? 20 square. And finally you get 10 root 5 or 22.5 meter. 22.5 meter. Therefore 22.5 is at A. The answer is A. The other thing is speed and velocity. Do the rest for 2 questions by yourself. And speed and velocity. Speed is the rate of distance covered with time is called speed. Therefore speed is dependent on distance. And the scalar quantity, since distance is scalar, speed is also scalar, and the symbol is v, and dimension of this velocity is what? M? No, it's not M. L times t the power of what? Minus 1. And the units for speed is meter per second. It's SI units, but sometimes we can use centimeter per second and so on. Types of speed, we have uniform and non-uniform speed. You can read this by yourself. Let us see what I mean by average speed first. Average speed is distance traveled, the total distance traveled divided by what? Total time taken. If you take the total time and the total distance moved by the object, you are calculating what? Average speed of the person. And the other thing is instantaneous speed. When we say instantaneous speed, a speed of an object at some particular instant time. At some particular instant time is instantaneous speed. That means when we take change in t, v is equivalent to change in s over change in t, and this change in t goes to approximately 0. That means at a point the change becomes 0 if you take at a point. Therefore the speed of an object at a point is named as instantaneous speed. The second one is velocity. Velocity is what? The rate of change of position. And the rate of change of position, that means the rate of change of displacement. And it's what? Scalar. No, it's not scalar. It is what? A vector quantity. It's vector. The dimension is what? L to the power of minus 1. And the symbol or the SI unit is what? Meter per second. And the types of velocity are so many. Among these we'll see what? Uniform velocity, average velocity, and instantaneous velocity. When we say uniform velocity, an object moving with what? Constant velocity. That means unchanged. When we say unchanged or constant velocity, the direction of the object or the direction of the velocity as well as the magnitude is what? Similar. When we say average, from the name, as we said before, the total displacement divided by total time taken gives us the average velocity. The other thing is instantaneous velocity. Instantaneous velocity, just like instantaneous speed, a velocity of an object at some instant time, where change in time is approximately goes to what? Zero. And the comparison between instantaneous speed and instantaneous velocity is always what? Tangential to the path followed by the particle. While thrown a stone, you can see from this diagram, therefore these are the instantaneous speeds. But the direction of this velocity can be found using what? The drawing tangent line. This one is the instantaneous velocity, but this one is the instantaneous speed tangent to the curve. And B, particles may have a constant instantaneous speed but various instantaneous velocities. For example, when a particle is performing uniform circular motion, then for every instant time the circular speed is what? Constant. But at any instant time there is change in direction. Because of this, velocity changes. And see, the magnitude of instantaneous velocity equal to what? The instantaneous speed. The magnitude is similar. And if the particle moving with constant velocity, then the average velocity instantaneous are always equal. And if the displacement is given as a function of time, the derivative of the displacement gives us what? Velocity. Okay, let us see some solved problems. Among these, I will show you one, and you do the other by yourself. In question number 4, problem 4, a car covers 2/5 of the total distance with a speed of 3/5 distance with u. V1 is 2/5 of the total distance, and V2 is what? 3/5 of the total distance. The average speed is how much? Always to get the average speed, we use what? Total distance traveled over total time taken. And total distance is, let us say it's x, we don't know, and t1 plus t2, because we have 2 times 2/5 and 3/5. Therefore, x over 2/5 of x, the displacement, is covered by v1, and 3/5 of the displacement is covered by over v2. This one gives us, this one is t2 and this one is what? T1, because t is equal to what? T is equal to, as you know, v is equal to s over t, and from this t is equal to what? S over v, and s is the covered distance is 2/5 divided by v1 for the first, and 3/5 distance is covered by the second speed, therefore over v2. And rearranging this, you can get finally x is cancelled from both, and 5 times v1 v2 divided by what? Twice of v2 plus 3 times v1. Then if you substitute the values, no, we don't have any value, therefore our final answer becomes this one, and this one is located at D, therefore the answer is D. Let us add one question. A car accelerates from initial position and then return to its initial position. Then the velocity of the car, the velocity is 0, but the speed is increased. The speed is 0, but the velocity is what? Increase. Here you must take the distance and displacement knowledge or expression, but this one is not right because the speed is not 0. Therefore, when the car moves forward and backward, the displacement is large, the distance is large, therefore it is not 0. And both speed and velocity decreases. No, they don't both decrease. Both speed and velocity increases. This is not true. But here the velocity is 0 because since the car returned to its initial position, the displacement is what? 0. Because of this, the velocity is 0. But the speed is not 0 or decrease. It increases because, for example, the car starts from this point, moves to this direction, and after that, if it returns, if this one is 1 meter, it becomes what? 2 meters of distance. Since the distance is increasing, the speed is also increasing. Therefore, the answer is A. The answer is A. Do the others by yourself. There are so many. Do it. The other thing is acceleration. Acceleration. When we see acceleration, we will see two acceleration, that is instantaneous and average acceleration. The time rate of change of velocity of an object called acceleration of the object, and acceleration is what? A vector quantity, and there are three possible ways by which change in velocity occurs. The first one is when only direction of the velocity changes, and the second one is only the magnitude changes, and the third one is both the direction as well as what? The magnitude when it's changed. It's changed. For uniform circular motion, only the direction is changed. For motion under gravity, only what? The magnitude is changed. And in projectile motion, both direction as well as what? Magnitude changes. And 3, the dimension is what? L the times t the power of what? Minus 2. L the power of 1. That means the SI unit is what? Meter per second square. And we have so many types of acceleration. Among these, we will see only the 2. But let us add the uniform acceleration also. When we say uniform acceleration, the acceleration of an object which is what? Constant, unchanged. For example, gravity. Gravity is 9.81 meter per second square. Since this value is unchanged, if we consider free fall is what? Constant or uniform acceleration motion. Uniform. When we say uniform acceleration, the magnitude and direction of acceleration remains what? Constant during the movement. And the second one is average acceleration. When we say average, as we did before, average is the change in velocity divided by what? Change in time. Change in time. But instantaneous is similar to average in equation, but here acceleration instantaneous is equal to change in v over change in t. At this time, change in t is goes to what? 0. That means the change is almost 0 when you consider what? The velocity of the acceleration of an object at a point. At a point. This is the three accelerations. The three accelerations. Let us see some solver problems which is related to acceleration. First, there are so many. Among these, let us do one question. Let us do one question. Let us take question number 13. The position x of a particle varies with time t as x is equal to what? This one. And the acceleration of the particle will be 0 at a time t equal to how much? You'll do this by derivation. By derivation, you learn about derivative on grade 12. Let us neglect this. Let us neglect this because you don't know about derivative. Therefore, let us do one another. Okay, let us see question number 60. If the displacement of a particle is directly proportional to the square of time, then the particle is moving with uniform acceleration, uniform velocity, variable acceleration, and variable acceleration, but uniform velocity. Here, the displacement of a particle is directly proportional to what? The square of the time. That means acceleration A is equivalent to what? V over t. This indicates that S over what? T square. Therefore, the acceleration of a body or the displacement is, if it is directly proportional with the square of the time, the acceleration of the value is what? Unchanged or constant. And at this time, we have what? Uniform or constant acceleration. Therefore, we can say at what? Uniform acceleration. Uniform acceleration. Do the rest by yourself. There are so many. Let us see the graphs. Position time graphs. The first one is displacement time. Displacement time, that is position time graph. Let us see the position time graph. As you see, from position or displacement time graph, we will calculate the velocity. The velocity. And to calculate the velocity, we will take what? A slope. Slope. And slope is equivalent to, according to your mathematics knowledge, slope is equal to y2 minus y1 over what? x2 minus x1. And in y, here we have what? Position. In x, we have what? Time. Therefore, s2 minus s1 over what? t2 minus t1 is the equation which we use to determine the velocity. And the slope of the graph in position time or displacement time graph gives us what? the velocity of the motion or the object. Therefore change in position divided by time taken, therefore y2 minus y1 over t2 minus t1, and y2 is replaced by s2 minus s1, s2 minus s1. Let us see. Okay, let us see the description of this displacement time graph. We have around 6 segments of this displacement time graph. Among these, the first one is the horizontal graph. As you see, in position time graph, if it is horizontal, the displacement is what? Constant. And since the displacement s is constant, the velocity becomes what? Zero. And for the second one, if it is, the time is constant and the displacement is moving with some value, and neglect this one is somehow it's advanced for you, and you have learned this on grade 12. Let us see the third segment. The third segment is a straight line constantly increasing graph. As you see, since it is constantly increasing, the displacement is what? Constantly increasing. Since it is constantly increasing, with time the velocity is what? Constant. The velocity is constant, and this constant velocity indicates that the acceleration is zero. And the third one is exponentially increasing graph. And the displacement is exponentially increasing. Since the displacement is exponentially increasing, the velocity is also what? Increasing. At this time, the acceleration is different from zero, and it's what? Positive. For the fifth graph, it's exponential decay or exponentially decreasing graph, and this exponentially decreasing graph indicates that the displacement is what? Exponentially decreasing. This decrease in displacement gives us a decrease in velocity. This decrease in velocity indicates that the acceleration is what? Negative or deceleration. Okay, the other thing is various position time graphs. That is, we have so many types of position time graphs, and when we interpret this position time graph, from the position time graph you can describe or explain or calculate the velocity. And to calculate this velocity, as you said before, we use what? The slope of the graph, and the slope of the graph gives us the displacement, the velocity. We have some examples here. Among these, let us see one example. The first one, question number 20. The position of a particle moving along x-axis at a certain time is given as this table, and which one of the following describe the motion correctly? The first one, uniform and accelerated. Let us see. First, you calculate what? The uniformity of the graph. And to get this, you calculate the velocity. And when you calculate the velocity from the first one, let us take these 2 points. That is 0 minus 2, 1 minus 0. 0 minus 2 is 2, 1 minus 0 is 1. Therefore, the acceleration is, the velocity is what? 2 meters per second. For the second, let us take this. 6 minus 0 is 6 divided by 2 minus 1 is 2. Therefore, it becomes what? It becomes 3. V2 is 3. And if you take this value, and 60 minus 6 is 10, 3 minus 2 is 1. Therefore, 60 minus 6 is 10, 10 over 1 is 10. Therefore, in each second, the initial is 2 and 6 and 10. Therefore, the speed is increasing at a constant rate. It increases what? By 2. From 2 to 4 to 6. From 6 to what? 10. Therefore, the velocity is what? Constant. The velocity is constant. But the speed is constant, but the velocity is not constant. Since the velocity is increasing, it's what? Accelerating. Therefore, A explains or describes the graph or the relation of the table clearly. Do the rest, since it's our example, do the rest by yourself. Let us see velocity time graph. The graph is plotted by taking what? Time in the x-axis and velocity in the y-axis for velocity time graph, and the distance and the displacement is calculated. No, it's not the distance. Actually, it's the displacement is calculated by using the area under the graph, and the slope of the graph gives us what? The velocity. No, the acceleration. The slope of the graph gives us acceleration, and the area under the graph gives us what? The displacement of the graph, the total displacement of the motion. And to do this, we have some examples. Before the example, let us see some segments of the graph. Let us take this, and these 4 segments of the graph. The first one, as we see in displacement time graph, the velocity is what? Constant. Since the velocity is constant, the acceleration is what? 0. The acceleration is 0. For the second, the velocity is what? Constantly increasing. Since the velocity is constantly increasing, the acceleration is what? Constant, and since it is increasing, it is what? Positive. For the third, exponentially increasing. What? The velocity is what? Exponentially increasing. For this reason, the acceleration is also what? Exponentially increasing. That means the velocity is increasing as well as what? The acceleration is increasing with some value. And for the fourth, exponential decay. Since it is exponential decay, the velocity is decreasing as well as what? The acceleration is decreasing. This is some description of the graph. We have some problems. Let us see 1 or 2 questions. Let us see question number 27. In question number 27, a train moves from one station to another station in 2 hours of time, and if its speed time graph during the motion is shown in the figure, the maximum acceleration during the journey is how much? To get the maximum acceleration, always you must take increasing graph first. We have increasing graph, this one and this one. Therefore, we can get a maximum acceleration from these two segments. Therefore, to calculate the maximum acceleration, let us take for A to B. For A to B, the distance is from 0 up to 20. Therefore, 20 minus the velocity 20 minus 0 divided by, for the time is what? 0.75 minus what? 0. And this one becomes 20 over 0.75. That means let us multiply this 100 over 100. This one becomes 2000 divided by 75. When you divide, you will get around 26.66 and 67 kilometer per hour for this segment. For the second segment, this one is 1 hour, and at this point is what? 1.25 hour. Therefore, the displacement is the speed is 60 and 20. Therefore, 60 minus 20 divided by 1.25 minus what? 1. And this one makes us what? 40 divided to what? 40 divided to 0.25, or this one is equivalent to 4000 divided to 25. And finally, you will get how much? 160 kilometer per hour square. Therefore, which one is greater from these two? This one is greater. Therefore, you'll get from C to D graph, and you'll know, or you'll see for the difference between the two graphs. And this one is steeper to y-axis, and this one is what? Steeper to or lower than in steepness from C to D graph. Therefore, if first to get the maximum value, you select increasing graph. From the increasing graphs, you will select what? Steeper to y-axis graph. Therefore, the steeper to y-axis graph is C to D. You can get the maximum value from C to D. It's what? 160 kilometer per hour square. Do the rest by yourself depending on the velocity time graph. Okay, the other thing is motion in one dimension, that is uniform accelerated motion. There are various relationships between u, v, a, t, and s. That means the initial velocity, the final velocity, acceleration, time, and displacement. And the basic relation between these all is the equations, the 5 uniform accelerated motion equations. That is, The first one is v is equal to u plus at, and the second one is s is equal to u plus v over 2 times t, and the third one is s is equal to ut minus 1 over 2, no, plus 1 over 2 at square, and the third one is s is equal to vt minus 1 over 2 at square, and the fifth one is v square is equal to what? U square plus twice of s. These are the 5 equations related to each other. Therefore, these are the 5 equations which are expressed here, and this one is the square, this one is v square minus u square, which is equal to twice of s, or you can shift this and v square is equal to what? U square plus twice of s also. Therefore, these are the 5 equations. And these equations are important for uniformly accelerated motions. In one-dimensional motion, the uniform accelerated motion example is free fall. Let us see free fall. Before that, the variables are 5. The first one misses what? S, and the second one misses the final velocity, and this one misses time, and this one misses the acceleration, and the last one misses what? The s, v, t, a, and it misses what? U. No, u is this. The fifth equation is not right. The fifth equation is s is equal to vt minus 1 over 2 at square, and its u is missed. Therefore, from the 5 variables, one is missed in each example, in each equation, as you see in each equation. Let us see, in each equation one variable is missed. Therefore, here s is missed, v is missed, t is missed, a is missed, and here u is missed. When you calculate, or when you use these equations to calculate some problems, you must select, or you have 3 givens and 1 required. Therefore, there are 4. Among these 5, 1 is missed. For example, if s, t, u is given and acceleration is required, what is missed? The final velocity v is missed. Therefore, you must select v missing equation. By using this technique, you can determine the required value. And how we can use this equation is, we have some problems here. Let us see one example, or one problem. A body A moves with uniform acceleration a and 0 initial acceleration. Therefore, let us take out the givens. The first one is acceleration is a, and the initial velocity is what? 0. And another body B starts from the same point, moves with the same direction with a constant velocity v, and the two body meets after t, and the value of t is how much? For the body A and body B is moving with the displacement of body B is equal to, since it is moving with constant velocity, v times t. And for body A, the displacement s is equal to, the acceleration is given and the initial is given, it's what? Ut plus 1 over 2 at square, and this u is 0. Finally, you get what? 1 over 2 at square and st. And since they are meeting, sb and sa is what? Equivalent. Therefore, 1 over 2 at square is equivalent to what? Vt. From both sides, t is cancelled, and finally t is equal to, multiplying both sides by 2, at is equal to what? 2v, and finally t becomes what? 2v over a. Therefore, 2v over a is on a. The answer is a. Do the rest by yourself. It's solved problems. Therefore, you can get the steps as well as the final answer from the question. The other thing is motion of a body under gravity, that's free fall. If a body is dropped from some height, if it says dropped from some height, the initial velocity is what? 0. And for any free fall, since it is motion under gravity, gravity is a constant acceleration. you must use what? You must use the uniform accelerated motion equation, the five equations, what we have seen before. You must use the 5 uniform accelerated motion equation for such problems. Okay, let us see some examples which is related to this. Let us see one. Question number 51. If a body is thrown up, since it is thrown up, it's projectile, and with a velocity of 50 meters per second, then the maximum height attained by the body is g is equal to 10 meters per second, and you are asked to calculate h max. This one is projectile, it's not one dimensional, it's what? 2D. If the object is thrown vertically up, and let us take one vertical motion. Let us see question number 55. A man drops a ball downside. It says what? Drops from a roof of a tower of height this much. This one is S and this one is U is 0, and at the same time another ball is thrown upside with a velocity of how much? 50 meters per second from the surface of the tower. Then they will meet at which height from the surface of the tower? That means S1 is equal to S2. But first H1 or S1, to get S1 is equivalent to, since U and 0 is U is 0, then S is equal to UT plus what? For the first one, H, let us say it H is equal to UT plus 1 over 2 H squared, and this one becomes 0, and finally H1 is equal to what? 1 over 2 AT squared. This one is the first equation. For the second, since it is thrown, it's what? H2 is equal to thrown upward, therefore UT minus 1 over what? AT squared. Since this minus comes from gravity is down and initial velocity is up, they are opposite, therefore we make one of the two negative, and these two equations are equivalent. You start from that, then, or H1 plus what? H2 is equal to what? 400. Then this one gives us UT is equal to what? 400, because this part and this part is cancelled out and only left with UT, and U is known, the initial velocity is given. Then from this, T is equivalent to 400 over what? U, and U is given. U is how much? 50, therefore 400 over 50, 0 is cancelled by 0, and by 5 it's what? 8, therefore 80 meter is the point where they meet. That means H2, no, after 8 seconds they meet. Then if you substitute at this point 8 seconds, 8 squared is 64, 64 times 10, it's 640 divided by 2, it's what? 320, that is H1. And if you substitute here also, you got how much? 80. The sum of the two becomes what? 400. Okay, this is all about one-dimensional motion. Do the rest of the example by yourself. Until next time, have a nice time.